Dear professors, students, and colleagues. So here is the Systems Analytics Global Leaders Seminars. So the objective of these seminars is to invite global leaders in industrial systems engineering, management science, and different application areas like energy systems to share their insights and innovation idea to the audience, and also nurture the young generations focusing in these areas. So today we are very happy and honored to invite and host Professor Henrik Lund to give us a seminar. So the topic of the seminar is the smart renewable energy systems and the fully decarbonized society. So before the start of the seminar, let me briefly introduce Professor Henrik Lund. So so can you see the screen now?
I see the screen, yes.
You can see the screen, yes.
Yes, please.
So okay. So Professor Henrik Lund is a professor in energy planning at Aalborg University in Denmark. He holds a PhD in implementation of sustainable energy systems in 1990, and a doctor of technology in choice awareness and renewable energy systems in 2009. So Professor Henrik Lund is highly ranked world leading researchers. He is listed among the ISI highly cited researchers, and the site ISI systems ranked him among the top 1% researchers in the world within engineering. Besides that, also Professor Henrik Lund also have many years of management experiences as a head of department, as a head of sections, and also a head of research group. So during his time, the Sustainable Energy Planning Research Group at Aalborg University has now grown to approximately 30 staff members, including 4 professors. And also, Professor Henrik Lund is the editor-chief of Elsewhere's high-impact journal, Energy, with annual 10,000 plus submissions. And finally, Professor Henrik Lund is also author more than 200 books and articles, including the book Renewable Energy Systems. He is also the architect behind the advanced energy system analytics software called Energy Plan, which is a free used worldwide, and have formed the basis of more than 200 peer-reviewed journal papers around the world. So without any further delay, let's welcome Professor Henrik Lund to give us the seminar. So Professor Henrik Lund, please share your screen.
Thank you very much. I'll just share my screen here. Can you see my slide now?
Yes.
Yes.
Yeah, great. Thank you very much indeed for this very kind welcome and introduction here. I have prepared a speech on smart renewable energy systems and a fully decarbonized society. And I also been asked if I can maybe afterwards, when you have the question, say something about the Journal of Energy, and I will be very happy to do that also during the question session. But I will put forward my presentation here first, and then afterwards I'll be very happy to both answer questions, but also, of course, to discuss and enter into a discussion of. There are many things that should be discussed these days on how to do renewable energy systems and everything. Let's see, I'll just have to do like this then. First of all, I'll just say where I come from. I come from Aalborg University, as already mentioned here in the introduction. Aalborg University is located in the northern parts of Denmark, and Denmark is located in the northern parts of Europe, as you can see here. And where I come from, it's quite interesting place to have my university and my daily work, because just outside the doors, there's a really big full-scale experiment going on with Denmark. First of all, we have built a lot of wind turbine, and as we speak right now, the wind turbines in Denmark produce annually 50% of our electricity supply is wind right now. What is maybe, I think that it's pretty well known that we have a lot of wind turbines in Denmark, but it's not so well known is also that we have a very high share of district heating and also combined heat and power production. All over Denmark, half of our heating of the houses is actually used to be produced in combined heat and power, saving a lot of fuels and then distributed with district heating. But when I say used to be, it's because as we implement more and more wind, of course, the whole idea is to close down the power production, and then of course we will not have so much combined heat and power production any longer. So we also need to replace our heating production, and I'll come back to that. One recent development, and it's actually expanding so fast that my numbers here on the slide is not correct. It's stated here that 10% of our natural gas supply is from biogas. That number has actually increased to 20, at least 20, maybe even 25% of the Danish natural gas supply is actually produced now as green gas on biogas. Biogas that is produced on manure from our pork farming and agricultural industry, and also other types of biomass input for that. So that was just a little bit about where I come from and who I am and how we work with this in Denmark. Then it was also mentioned in the introduction that I'm the author of this book, Renewable Energy Systems, and in the second edition from 2014, there's a new chapter on smart energy systems and infrastructures, and that is primarily what I'm going to talk about today. So if you need more information, there's a lot of things to be gained here from in this book here. In the book, I talk about renewable energy systems, 100% renewable energy systems, both how to design them for the future and also how to implement them from a political and implementation point of view, how we as a societies can go from the current energy system and then transform ourselves into the future green energy systems. And in the book, I call it renewable energy systems. But if you take a look at how we talk about it today, then we talk more and more about climate neutral. That's a much more broader sense. This diagram here is from one of the European Commission reports, where they have some visions about, they call it a clean planet for all. And they have some visions here on how the European communities could become climate neutral in 2050. And I will also come back to in the presentation how we then should look at renewable energy and the green transformation in the view and the eyes of these goals of becoming climate neutral. And this actually takes it to be a little broader. It takes it to be that we do not only look at the energy sector, but we also have to include the agricultural and processes in industry and similar things into the overall consideration, because they're also climate emission gases from this industry, even though they are not all of them carbon dioxide, but they also have the climate change effect, and somehow we have to take that into consideration. And that's quite important when we look at the energy sector, because as I see it, and when we have investigated this, it seemed very difficult, at least for a country like Denmark, but I think that's general for the world. It's very difficult to become carbon neutral in agriculture, as long as we have the need for food that we have right now. And for that reason, it will somehow need to be coordinated with what we do in the electricity and the heating and the industry and the transport, the whole energy sector, somehow to compensate for those things that we cannot bring totally to zero. So that's the new talk, that is to become climate neutral, and I will come back a little bit to that. But no matter if we call it 100% renewable energy, or we call it a fully decarbonized society, as political goals we wish to achieve in our societies, then of course the big question is how to do this. And this is where I believe that we, as the researchers, the engineers, and all the other researchers, we should do our job and come up with the solutions on how to do this, and also how to implement this kind of political goals. And that's what I have been involved in for several years in Denmark, actually for many years, to come up with proposals on doing this. For now, more than 15 years, I have been collaborating with the Danish Society of Engineers. So we have had a collaboration between the engineers and then Aalborg University in order to design and use all the skills we have in the Association of Engineers and at the university to design solutions on how we can do that. And I will also come back to that. So that is some of the activities we had. And then of course also we have had a lot of research project. This is a slide from a research project we had in some 10 years ago, where I headed almost all universities in Denmark in teaming up on identifying what to do with the biomass, how to convert to 100% renewable energy, and so forth. And I will also come more back to this in my presentation here. But first, I will say that the way we do this, the way we work, is that we use computers and computer models to replicate the energy system we have right now, and then of course to change it in the computer world and see what will happen if we in the future do this and that. If we keep building so many wind turbines as we do in Denmark, how can we then manage the electricity supply, and how can we design a proper solution for the future to go to a fully decarbonized society? And as already mentioned in the kind introduction, I'm the architect behind this model here that we use at Aalborg University. It's called Energy Plan. It's a freeware, so you can go in and download it. And the surveys I will talk about here is all calculated there, and mostly often all the files and the data are available, so anyone can go in and replicate what we have been doing. One thing I would like to emphasize here in the beginning is that all the studies we have made on this throughout the years, not only for Denmark, but also for Europe and also for other countries, and also for cities and towns and so on, all of them sort of, in our experience, come down to one very, very important conclusion out of all this. And that conclusion we have tried to express in the term that we have written a lot about in scientific journals, that we call the smart energy systems, smart energy systems approach. And what we're trying to say with this approach is that you can go to 100% renewable energy or decarbonize in many different ways. But if you want to do it in a doable and affordable way, and want to identify the least cost and the best way of doing it, then it's essential that you take a holistic approach, a cross-sectoral approach. It's essential that you do not try to do it in the electricity sector on its own, and then afterwards in the heating sector on its own, and then the industry and the transport and so on. It is essential that you do it together, because there are so many synergies between the sectors that you should exploit and identify and use, and then you'll be able to do it so much more better and affordable. And just to mention the energy system analysis model, energy plan that we are using and have developed, we have developed it with that purpose, so it can do that. So we can make very detailed hourly simulation of not only the electricity sector, but also the district heating and the hydrogen and the gas and cooling and liquid fuel and so on, and everything. And not only each of them on its own, but all of them together. And the reason why this is incredibly important is that then we have a tool in which we can play around with putting a lot of wind turbines in, and also different types of conversion unit between the different energy sectors, and also different types of storage. And I'll come back to why this is so essential that we can do that. But before coming back to that, I'll just take a little bit and talk a little bit about smart grid and smart energy systems. I mean, the reason that we talk about smart energy systems is because somebody started talking about smart grid, and I guess we all know this term, and it's not that I have anything against smart grid. Certainly, I don't think we should do dumb grids or stupid grids or anything like that. Of course, we should be smart everywhere. But this term, smart grid, as far as I have been able to see, came into the language in 2005 with this article here, Toward a Smart Grid. And this is actually an article written by power engineers, and they just say the very simple and obvious thing that now we have developed the modern computer. Why not use it and use the communication technology whenever we do whatever we do in the electricity sector? No matter how we use the electricity with the consumers, or how we distribute it, or how we transmit it, or how we produce it. Then we could do it so much smarter, and that's they don't have a definition of it, but that's what they call a smart grid, and that's where I can find it mentioned the first time. But there's no definition there. Then I've been looking for a definition, and the interesting thing is that the scientists, the scientists, never really defined smart grid. There's no really scientific, at least not in the early days, definition of smart grid. Those who defined smart grid were the organization that started to grant money for research in smart grid. And because they were granting money for something, they had to define what it was. So this is the US Department of Energy, it's the European Commission, it's the International Energy Agency, and so on and so forth. But the interesting thing is they all have different definitions. It's not the same, but they look like one another. There are things that are the same. One thing that is the same is that, of course, this use of being smart with communication technology and so on. But also one thing that is the same is that only talk about electricity. So it's only being smart on the electricity grid, not on the other grids and infrastructures we have. Then later on in 2010, the European Commission in a document starts talking about smart grids, and not only smart electricity grids, but also smart heating and cooling grids. So we cannot only have to be smart with the electricity sector, but it could also be in the other sectors. But still, smart grid is mostly used only for the electricity sector. So based on this, in my book, Renewable Energy System, and also in a paper before this new edition came, I tried to define smart energy systems and also smart electricity grid, and what I then call smart thermal grids, heating and cooling, and also smart gas grids. And then I say you can define smart grids within all these sectors here. But if you really want to be smart, then you should do a smart energy system. And then I defined a smart energy system as an approach in which not only we are smart within the individual sectors, but we are also smart across the sectors. So we also use the synergies between the sectors, and that's sort of the idea behind this concept here. And some years ago, we published this. I published something about it in 2012, as you can see here in the book. I already mentioned that. And then I made a review paper with some colleagues in 2017. We've sort of analyzed the use of this concept here. And as you can see, it's been used increasingly, and it's also being used more and more to express exactly this approach of being cross-sectoral and being holistic when you are being smart. And that's also the focus I have in the book, and what I also write there is that if you are only looking at the electricity sector, then you would trick yourself into some solutions that would be to build electricity storage or have flexible electricity demands, or transmission line to other countries. Something like that will very often be the solutions you come out with if you exercise smart grids in a green transition with a lot of wind turbines and so on. But in my view, those solutions are not very smart, because the procedure of having this approach only looking at the electricity sector leads you into solutions that are not very cost effective and not very smart. While I will argue that if you take the smart energy systems approach, then you'll identify other solutions, and those solutions are cheaper and better and more doable, and also will lead us into a holistic way of the whole green transition in a more affordable and more doable way. Now the question is, why is it so? Why is it so that this broader approach will take you to the better solutions? That's what I'll try to talk about now. One thing that is really important is the fact that the cost of storing energy depends heavily on what type of energy you are storing. And here I compared the different ways of storing energy. There's one I have called electricity. Now you cannot store electricity, but what I mean here is that you have a storage where you put in electricity and you take out electricity. Of course, that could be a battery. It could be a pumped hydro, as here on shown here on the picture. Or it could be converting into hydrogen and back again, or whatever. So there are many ways of doing this. There are many ways of electricity storage, but what they have in common is that the cost, the investment cost of buying access to, for example, storing 1 kilowatt hour, as shown here, is so much more expensive, than the investment of buying access to store 1 kilowatt hour of thermal energy. And it's actually 100 times more expensive, give and take 1 or 2, but in that order of magnitude. And here storing thermal energy is shown to the upper right here. as a thermal storage from one of the Danish small combined heat and power production units. It's simply just a big tank of water. And that again is more expensive than storing natural gas. Here's a natural gas underground storage, but that of course could also be in the future green gas. And that again is more expensive than storing liquid fuel. Here it's a lot of oil tanks, but in the future that could also be green liquid fuel, methanol or similar. Sorry. And this just tells me that if we can organize and redesign the energy system in a way so we don't force ourselves to store electricity, but can store the energy we need to store as either thermal energy or gas or liquid fuel, then it's so much more affordable. Then I also have this diagram. This is sort of, if you only look at thermal storage and then compare in a store in each house, that's to the upper right. I don't know, can you see my point here? Can you see that? Yeah, you can see here.
Yes.
It's thank you. It's a individual storage in a house, and then compare it if we do it together, like here, where it's storage on a district heating level. And again, this is 100 times cheaper, more affordable to do that. But not only is it much cheaper, it's also more doable, because actually in this, what we look at here is Skagen in the northern parts of Denmark, the district heating company. They have in that storage 4 cubic meter of water for each household. And that's really difficult to put into a flat. Especially in Hong Kong, I would say that would be very, because if you take a look at it, 4 cubic meter actually is a tank this big here, and that's very difficult to have in each flat to do that. So it's also more doable if we do it together. And then I also brought the number from some recent solar thermal seasonal thermal storage we have building in Denmark, and then it's even a factor 1,000 from here to here. So again, it's so much more doable and cheaper and affordable if we, by use of district heating grids, store it together instead of storing it, each of us in each house or each flat. It's a little bit the same story with electricity storage, but not as obviously. The price difference is not as big as for thermal storage, but still it's more affordable to do it together than do it in each house. I mean, I put down the Tesla power wall here, and if we in Denmark, with all the wind turbines we have already and the ones that we are going to build, should store that in Tesla power walls, it will be impossible. Even though if we had in every single house, we should have many of them in every single house, and it will cost extremely many money to do that. So that's not really a way to go. Not say that this is a bad solution. This is a solution to charge your car, and that's perfectly well, but it's not a solution that can help us as a society to integrate all the wind we have. Sometimes I ask about the prices here, and I'll just leave this link here. So here is a paper we have written about the prices and where we have them from, and it's real prices that we use here. So that's one argument why it is so much better to look at it in a holistic way, because then we don't corner ourselves up into, if we only look at the electricity sector, to have a lot of electricity storage. Now with interlinking and have a cross-sectoral approach, then we can identify better solutions and cheaper storage options. That's one reason. The other reason is if we take a look at the storage we already have, this is again from Denmark. I mean, we have a lot of oil storage, that's all our oil tanks. We also have a lot of underground gas storage. And if we put together all our thermal storage in all our houses, hot water tanks, together with all we have in district heating and so on, then we have a little bit, as you can see here, the little red one. If I should put on this diagram our electricity storage capacity in Denmark, you couldn't see it because that's almost not there at all. But and when shifting to the next slide, I'll just say that we also try to identify. Sometimes I have said, when people say we need a lot of storage in the future energy system because of all the wind turbines and PV and so on, I have said not really. In fact, we do have more or less the storage we need, almost. What we need is access to the storage. And what I mean here is that we have a lot of storage capacity, for example, in the Danish underground gas storage, and many countries around the world have similar storage capacities. But we do not have access to put the wind power into the gas storage. Then we need to have some conversion units that can produce hydrogen, and that hydrogen can be together with some carbon, and then we can produce some methane, and then we can put it into the storage. And when we analyze it, and now I'll show the next slide here, this is what we think we need in a 100% renewable energy Denmark in the year 2050. This is the storage capacity we need in order to balance that in all sectors, both electricity, heating, cooling, transport, etc. And as you can see, it's almost the same storage regarding the liquid fuel and gas storage. Now, of course, it will be green gas, and that will be green liquid fuel. We need some hydrogen storage. And when we have a lot of hydrogen storage in our proposal on how to do this, it's not because we wish to have a lot of hydrogen supply and hydrogen storage capacity. It's more storage capacity so that we can be flexible on the electrolyzers, so we can produce the hydrogen in when the wind is blowing, and then we would like to convert the hydrogen with carbon onto methane and then store it here, or methanol or the similar green liquid fuel, and then store it here. And if we look at even if we put electric cars in all cars in Denmark, this is the storage capacity we will have. So it's not really big, but of course, if we do that, of course, we should do smart charging, no doubt about that. But that's not what will really do the job. What will really do the job, of course, that will help. What will really do the job is when we can convert the wind power into thermal energy in heat pumps, and we can convert it into hydrogen, and further on to with power to gas. That's when we get the storage access to the storage capacity. A third reason why smart energy systems approach is urgent is if we look at the infrastructures we have right now. I made this drawing because in Denmark we had a lot of political debate, and it was as if everybody thought that the biggest grid we have in Denmark is the electricity grid, but that's not the case. As you can see here, the capacity of the natural gas and district heating is twice as big, each of them, as the electricity supply in Denmark, and this is the total supply for everybody. And this also, but just by looking at these numbers here, this diagram, you can see if we were to electrify everything in Denmark and convert all heating to electricity and all natural gas to electricity, then we will have to expand our electricity grid enormously. And I have sometimes calculated how much, and you come to really big numbers of cost if you identify how much you have to expand the electricity if you're not using the other ones. And there till you can add that if you have a district heating grid, then you can recycle a lot of waste heat from industry and also in the future power to X from the electrolyzers, so on, waste heat from that. And also right now there's been built a lot of data centers in Denmark, and there will also be a lot of potential waste heat, low temperature waste heat, you can recycle if you have a district heating grid. So for that reason, it's also a matter of having district heating grid. Now we have a lot of district heating in Denmark, so not all countries will look like this. In many countries in Europe, the red one, the district heating, will be lower, and the yellow one with natural gas will be higher, because there's really a lot of natural gas being burned in Europe in individual houses. So that's the reason. So and then I'll just add to what I said here, that this is why we can identify so much more affordable solution if we take this holistic approach. Then I'll go a little bit more into what are the other synergies in the different sectors, and I'll start with the power to heat sector, sort of where we convert wind power to heat, and why could that be a good idea? First, I'll show this diagram here, and that's here you can see that in terms of energy efficiency, we have been able in Denmark to decrease the amount of heat while we have increased the space, and this is simply by insulating the houses throughout many years. We also expanded the district heating. As I mentioned already in the beginning, we have come to a extent in which half of the buildings were heated by the combined heat and power in Denmark. It's decreasing now. And for that reason, actually, if we look at the fuel we have used for heating our houses, then you can see we have really converted it. Now this one is a little old, but it's more or less the same numbers we have now as it used to be. Only we are still decreasing the oil and gas for individual boilers and increasing renewable energy. And when we then look into the future, we have discussed a lot in Denmark, and I also led a research center for several years, also with the Chinese participant, where we looked into the future technologies of district heating, and where we defined what we call the fourth generation district heating. Because you can, of course, ask yourself, now we used to have a lot of benefit of combined heat and power, because we had to produce power and then we can recycle the heat for district heating with very low costs and very low energy fuel consumption to do it. But if we are replacing all the power stations with wind turbines, would it then be a good idea to have district heating at all, or should we stop having that? And our answer to that is, it's certainly very much a very good idea to keep on having district heating, and we suggest even to expand it. But we also say that district heating also have to adjust to the new situation. And the way district heating should do that is to convert to what we call fourth generation district heating, and that is mainly to lower the temperatures. Because in the future, first of all, the houses will be insulated and use less energy. So if you don't have a more efficient distribution, then you'll have the percentage of losses will be so much higher than your consumption, and that's not good. So for that reason, it's good to have well insulated pipes in the future, and also to decrease the temperature. But what is more and even much more important is that the sources for recycling and producing district heating in the future, all of them have the characteristic that they really benefit from being able and being allowed to produce with very low temperatures and not with high temperatures as today. And we suggest to going down to around 60 degrees, maybe 17 in the winter. And then have a return temperature of around 30, something like that. And no matter if it's industrial waste heat, or if it's geothermal energy, or if it's heat pumps, or whatever it is, then you can produce so much more and more efficient if you lower the temperature. So that's what we advocate to do. And also one of the things that we can see is that we need a lot of heat pumps in the district heating and also outside the district heating as individual heat pumps to replace all the oil boilers and gas boilers and so on. And for that reason, we'll have power to heat in a very efficient way, because the power from the wind turbines will then be exchanged in the heat pump to 3 times more energy or even more. But what is also important here is that if we foresee that because of the green transformation of the heating sector, we need to have some power to heat in heat pumps, then we can ask ourselves, why should we then store the excess production of the wind turbines when it's electricity? Why not wait until it has been converted to heat and then store it? Because as I showed earlier, that's 100 times more affordable. And that's, of course, what we also do when we design these systems. Then sometimes you have to invest in a bigger heat pump, and of course the thermal storage, but the benefit of that compared to avoiding the electricity storage is so high that it really improves the cost of the system. We have calculated this also for the whole of Europe in something we call Heat Roadmap Europe, where we have calculated and showed how much you can actually gain from having district heating. We actually also made something we call Heat Roadmap China. There's a small paper about that also in the scientific literature. We also made a small video on it. If you have access to YouTube, you can go in and have a look. Now I'll say something about power to transport, because when you made all the power to heat you need for the heating sector, then you have not been still not able to make all the flexibility you need for the wind turbines. But if you then take a look at the transport sector, I mean, what we should do in the transport sector, of course, is to use as much direct electricity as possible. Electric cars, electric trains, electric vehicle in any sense and forms is the best. But when it comes to aviation and shipping and maybe some of the long distance heavy duty vehicles, then that's not doable. So for that reason, we'll have to do something else. Here you see a diagram and in the book there are a number of diagrams sort of showing how we can go from electricity to transport. And here it's easy when it's cars or electric cars or trains, then you can do it directly. It becomes a little more difficult if you have long distance driving or you have heavy vehicles and so on, and especially when you go to aviation and shipping. And what I just mentioned, I cannot go in details with all this, but we'll just like to say that, of course, some of it should be direct electrification, but also for those parts of the transport sector that we cannot do direct electrification, we can do indirect by producing gas and especially liquid fuels, combining the hydrogen we can get out of the wind turbines and the biomass, the carbon from the biomass and straws and so on. And there are different ways of doing that. Power to X, it's been called now, or different. But no matter if it's the one or the other, this is power to transport. And there's a lot of losses in that, but we have to accept those losses, not because of the wind turbines and the integration of renewable energy and so on, but because of, if we don't, then we cannot transform the transport sector into renewable energy. Then we cannot get rid of the oil in the transport sector. And if we sort of accept that we have to accept those losses, then we can again ask ourselves, why then store the electricity from the wind turbines as electricity, why not wait until we have converted it to green liquid fuel or gas? Because as I showed earlier, then it's so much more affordable to store it. Then of course, if we wish to make this flexible, then we may have to overinvest in bigger electrolyzers and a hydrogen storage. But in our experience, when we do this type of calculations, that is much more affordable than having an electricity storage. Again, the same point. And that's why we have some hydrogen storage and overinvest in electrolyzers. And by the end of the day, it will be comparing, on the one hand, you could build more wind turbines and then throw away more excess production from them, or you can build less wind turbines and then build more electrolyzers and then use it. And then you can weight those investment costs against one another and identify a more or less optimal solution. And in our experience, there will always be some electricity that it will be so expensive to catch by the end of the day that we should just have it as excess production and have it lost. But there will be some that it can pay to catch. And that's the cheapest way of catching it, in our experience, is to overinvest in electrolyzers and then catch as much as is affordable to do. Okay, I come back to this project here I mentioned in the beginning. There we looked very much into the detail of transport. We identify all the ways of doing it, and we also, by the end of the day, identified a complete 100% renewable energy. And we came to the point that when we sort of identified this and identified the best way of electrifying the transport sector within biomass that is limited and be limited to the sustainable part of the biomass, then our consequence was that we need a lot of wind turbines, but we didn't really need any electricity storage. We could do with liquid fuel and gas storage. And we already have that liquid fuel and gas storage. So what we need is the conversion units that we need anyway. We need to charge the batteries in the cars. We need to build the power to X units so we can produce this gas and liquid fuel. Now time is running, so I will turn my head now to this slide that I already showed in the beginning. That is the purpose of becoming carbon neutral. And also here, but how can we become carbon neutral? And I'll just say some results from a study we made, Aalborg University, together with the Danish Association of Engineers. We call it EDA, Danish Association of Engineers, that's short for that. In Danish, EDA's climate response, where we sort of come up with a concrete proposal on how we could achieve the political goals of becoming fully decarbonized in 2050, and already in 2030, the Danish Parliament have decided we should reach a 70% decrease in carbon dioxide emissions. And we sort of formulated, because you can do this in many ways, but if we should do it right, then we formulated these guiding principles here that I think is universal, so to speak, even though we use them on Denmark. But we say that if Denmark should do this in a good way, it only makes sense in terms of climate change for us to do that if all our neighbors, the rest of Europe, and by the end of the day, the rest of the world, including China, is also doing the same thing. So if we should fulfill this, then we should do it in Denmark in a way so that it fits well into that everybody is doing it. And this may sound simple, but it's actually a very good guiding principle, because when you have to do a lot of limitations and decisions on your study, then this is really something you can come back to and say, how should we do it if we should do it in a way so it fits into that everybody is doing this all around the world. For example, international aviation and shipping. If you look at the UN way of saying how much carbon we have in Denmark and what we should do, how much we should decrease it, then international aviation and shipping is not included. But that's not very good, because if nobody is including that, then we cannot go to zero carbon emissions in the world. So what we say is that Denmark should actually include our share of international aviation and shipping when we do this. Another issue is the biomass. I mean, not all biomass is sustainable. So what we say here is that we should do it in Denmark within the limits of our share of what is sustainable use of biomass in the world. And the next thing is, what about flexibility? Because right now, many countries, including Denmark, is building transmission lines to our neighbors. And then we build a lot of wind turbines, and then we think we can just export the wind when the wind is blowing and import electricity when the wind is not blowing. But we cannot all do that in Europe. Then everybody wishes to export at the same time, and everybody wants to import at the same time, and that's not doable. So what we say here is that, of course, we should trade between the countries, and sometimes the wind will blow in another way in one country than the other, and there's also Norwegian hydropower, and there's also more sun to the south of Europe than and more wind to the north, and things like that. And of course, we should trade and use the electricity grid to make the best out of that in mutual benefit. But by the end of the day, we cannot solve the problem with this, and then everybody will have to make a contribution to the flexibility and reserve capacity and storage capacity of the European electricity supply. And we should also do that in Denmark. So, and we should do that to a degree that, assuming that the others are doing the same, then we can actually solve the problem for the whole of Europe, and by the end of the day, for the whole of the world. So that's what we have been doing, and this is the Danish carbon dioxide emissions from starting from 1990, and then you can see we have already decreased it quite a lot here until 2020, and this is our proposal for 2030, and that will then implement the Danish goals of decreasing it by 70%. But it's not only energy and transport here, the dark blue, it's also agricultural and processes and industry and other things. And it's the total we have to break down. We also illustrate here but this is the way UN account. But if we add to the Danish carbon dioxide emission our share of international shipping and aviation, then our carbon dioxide emissions are actually quite much higher. And then it's much more difficult to go, and we are not really implementing it to 30% if we are doing what we are doing according to the UN counting. So for the future and for the fully decarbonized society, we have included that in our survey. And here you can see how we will then decrease all the sectors. And by the end of the day, we write here 2045 because we think we should be able to do it in Denmark before 2050. So we argue 2045. And here you can see that we don't think we can bring everything to zero. We don't think we can bring agricultural to zero or industrial processes. For example, we produce cement, and there's a carbon dioxide emission there from the process. And there'll also be, if we still have flights, flight contrails that we have to compensate for. So we have somehow to do something negative here, and that is what we will be carbon capture storage or biochar, sort of to compensate for the others. So that's part of what we have designed. And that will change Denmark in the following way. This is how we look now with a lot of fossil fuels. As already mentioned, we also have a lot of wind turbines. It actually produces half of our electricity consumption, but still we have a lot of oil for the transport sector and so on and so forth. In 2030, we'll have much more wind and solar, much less oil and gas, as you can see here. And then in 2045, according to our proposal, we will have a lot of wind, even more wind, than in 2030, and some biomass. That will still be our share of sustainable biomass in the world. And then we'll be able to produce also international aviation and everything in this proposal here. Just a little bit about the biomass, because that's quite tricky. I said before that we wish to limit our proposal so that we in Denmark only use our share of what is sustainable biomass in the world. But this also means that we should also contribute with our share in Denmark what we can produce within sustainable biomass to the world, so to speak. And we have a lot of manure, straws, woods, and so on that we can develop and then try to convert to usable gas and oil and so on for the transport sector, but also from the industry and so on. And we propose to use all this biomass in a multi-technology strategy way, so to speak, where we have both biogas plants, pyrolysis, thermal gasification, HTL, and so on. And the reason for this is twofold. The one is that not all these technologies will maybe be there on the commercial scale when we need them. We know how to build biogas plants. As I mentioned already, now 20% of our gas is produced from biogas, but can we also put straws into those biogas plants? We wish to be able to do that. And other technologies also have to further be developed. So that's the one reason. If one fails, maybe the other one can take over. The other reason is that there are some synergies again. I mean, if you put straws into biogas, not all of it can come out as gas. Some of it will come out as lignite and other things, but that could be put into a pyrolysis. If you take a HTL, not all of it will come out as something you can use, but also be a wet organic material that you could put into a biogas plant and so on. So this is sort of illustrated here in this diagram. And then we can also capture some of the carbon coming out of this, and then we can do carbon capture and storage and also biochar, as we also need to do in order to compensate for those the other sectors. I'll soon stop talking so we can have some questions and debate, but I will just mention that in order to implement all this, we have to do a lot of more renewable energy. We have to expand wind power in Denmark from around 6,000 megawatt today to around 20,000 megawatt in 2040. That is 3 or 4 doubling what we have now. So that's a lot. Also, PV is also being expanded. We expand geothermal energy. We expand also maybe wave power, but at least also solar energy. Wave power is only a little bit, and it depends, of course, if we can develop it to a commercial level, or somebody else can do that. So we will be able to include that also. Just one slide here to the end, and that is the cost, because we very often ask, how much will this cost? And looked upon from a societal point of view, in our view, it will cost a lot of investment, but the annual cost of getting energy in Denmark will not really be higher than it would be anyway. I mean, we have here Denmark today, and then what Denmark would be in 2030 if we don't do anything of all this type of investment. And that will be higher because we then will be more people, and we also have more houses and so on, and the fuel prices will likely be higher than what they used to be. But if we then convert to the alternative that we propose, then we'll have to invest a lot, but we also save a lot of fuels. And the additional investment, the annual cost of paying back the investment additionally we have made, is in the same order of magnitude as the fuel cost we save. So it's more or less the same. But that's good, because I mean, depending on if we have unemployment in Denmark or not, available work labor, then it's a good thing, because then we can put that work labor into the investment, because many of the investment will be carried out by Danish work labor anyway, because it's putting down district heating pipes, it's putting up wind turbines and so on and so forth. So that will actually benefit the Danish economy if we do that. And also, and that's very important for the Danish Organization of Engineers, and for me also, when we do this, we also develop new technologies that we can sell and export. And in that way, there's an additional benefit for all this. So this sort of brings me to an end. I would just like to mention that we're not only calculated for Denmark, we also calculated for the whole of Europe. There's a paper about that. And we also calculated for other countries, and we also calculated it for example, Aalborg and other cities and municipalities. You can sort of use the same guiding lines and make the same type. And it should very hopefully be so that if we do in Aalborg what we propose for Aalborg, then it fits into what we should do in Denmark, and that fits into what we should do in Europe and in the rest of the world. That's what we try to achieve here, so that everybody, no matter if they are individual persons or they are municipalities or they are countries or they are continents like Europe, then we will all do what is best for us all to do in order for us all to achieve the common goal of decarbonizing the energy sector of the world by the end of the day. I'll stop talking now, and thank you very much for listening and being so patient. And I'll just stop this slide here with a lot of links where you can go and check up on some of the things I've been talking about. And then, of course, I'll be very happy to take questions and also engage in discussion and hear if there are any comments and contributions. So thank you very much for being so patient.
Thank you very much, Professor Lund, for giving us this very comprehensive and very insightful seminar. So now let's move on to the Q&A sessions. So if you have any questions for Professor Lund, please feel free to use the Q&A box in the Zoom. And also please type in your name and affiliations. Thank you very much. We already have many questions. So the first question is from Zhong Shu Ya. Hi, Professor Lund. Thanks for your presentation. What do you think the biggest challenges or bottlenecks are in demonstrating or applying the holistic smart energy systems approach? Thanks. Professor Lund.
Yes, that's the biggest challenge, if I should say that. And then I can say something, but please comment the rest of you also, because there could be many opinions upon. But coming from why we are promoting it so much as we are, the history of this is, and by the way, I'm an electrical power engineer myself from when I was a bachelor, is that we, the electrical power engineers, we sometimes are very narrow-minded and only look at the electricity sector. And we also very good at promoting concepts such as smart grid and so on. And I think also being the editor-in-chief of the Energy Journal, I see many scientific contributions, and some of them are very good, but many of them have this drawback that they only concentrate on one sector, for example, the electricity sector. And that is what I believe is the biggest bottleneck. That is the bottleneck of our minds to look at that. And there's nothing wrong about looking at the electricity sector, because we need to look at the electricity sector as we need to look at all the sectors. but it will be better if we look at the electricity sector in the context of how the electricity sector could do good for all sectors, and not only how the electricity sector on its own can become green, because then I think it's much more doable. I can mention we just made a survey here together with some of the Danish industry, where we are promoting the how to heat Denmark in the future. And instead of coming with a proposal on how the heating of Denmark could become green in the best way, we on purpose defined the goal for our studies to say instead how the heating sector, what the heating sector should be doing in order for the whole of Denmark to become green in all sectors the best way. So we're not only looking at the heating sector, but we're looking about what can the heating sector do to the holistic of the whole green transition of all sectors. And that's what I guess that's what I'm arguing here. And maybe that's the biggest bottleneck in my own head and in everybody's head, because sometimes this is a big challenge to be able to do that. It's not so easy as it sounds.
Okay, thank you very much, Professor Lund. And for the second questions, also from Shuya. Note that Shuya is a lecturer from University of Exeter, UK.
Okay.
And yeah, and Shuya works on logistic and supply chain management in renewable energies. So, Professor Lund, how would you see the role of logistics and supply chain network design and also optimization in the holistic smart energy systems approach? And is it an important side field to support the shaping of the holistic energy systems?
And then I have to ask, by logistics and supply chain, do you mean how to produce the wind turbines, how to get the steel and so on? Is that what you mean? Or is it when you have produced the wind turbines and they produce electricity? Is that, but this is my question, because I'm not really sure what is meant here by supply chain.
Yes, thanks. Maybe Shuya can have more information on the logistics supply chain network design and optimization. And maybe we can move on to the next questions, and we can wait to Shuya for inputting more information. And the next question is from Daniel. Good afternoon, Professor Lund. Thank you for sharing the successful case in Denmark. So Daniel is from HKU. So he wonders, like cities like Hong Kong, linking space and resources to generate entertainment, what will be the promising applications of smart renewable energy systems?
Yeah. So that I very often hear this, and now you're China and we are Denmark. Very often people say to me, "Yes, that's Denmark, and it's so small and so easy. What about China? That is so much bigger." And actually, in my book, together with Professor Xiliang Xiang from Tsinghua University in Beijing, I made a study once where we sort of calculated how big is the population in China and how big is it in Denmark, and how big is the square kilometers of China and how many in Denmark. And then we divided those numbers. And the interesting thing is that per square kilometer or per square meter, we are not more people in, you're not more people in China than we are in Denmark. You're just so much bigger, both in terms of population, but also in terms of square kilometers. And we also, in that paper, it's in the book, we also, and it's also a scientific paper, it's also out there somewhere. We also identified the resources, the renewable energy sources of China they do these potential resources, of course, the potential for wind power and so on and so forth. But these potential resources in China is also in the same order of magnitude per inhabitant as it is in Denmark. So, right, the job in China is much bigger than in Denmark, but you also much more people to do it. And per people, it's the same. That's sort of my argument there. Then, of course, I mean, if Copenhagen should do it on its own, then that will be difficult. So the rest of the country in Denmark will have to assist Copenhagen in getting enough wind turbines up and so on and so forth. And of course, you will have to do the same in China. You will have maybe not to put all the wind turbines up in Hong Kong and the islands you have there. Maybe some of the wind turbines you should use should then be in other places of China. And I know there's a very far distance to the north and where you have the available spots, but still, that will be my answer. Yes, it's much more difficult, but per people, it's per inhabitant, it's the same challenge.
Okay, thank you very much, Professor Lund. So any more questions? You can type in the Q&A box. Oh, so yeah, so Shuya has added more information. So he refers to the logistics and supply chain to, for example, moving the materials, equipments, people, vehicles, involving producing the energy, maintaining the infrastructures, and all the way from the manufacturers to the sites and then to the end users.
And my answer to that is, this is not something I investigated in details. So I'll be interested to hear what Shuya Xiong, what you come up with, if that's your field and you investigate it. But I'll just say, as an input to the debate, I don't see really why this should be more difficult compared to what we are already doing. I mean, distributing electric cars is not more difficult than distributing other types of cars. Right now, if you look upon the amount of energy that we are distributing in terms of oil and gas and so on and so forth, why should it be more difficult to, of course, in a phase where we have to expand the numbers of factories that can produce wind turbines and PV and all the things we need to build, then of course that will have to take some time in order to do that. There will be some supply chain involved. But I don't see really, and the bigger picture, that should be more difficult than the thing we are replacing.
Okay, thank you, Professor Lund. So yes, I also have a questions on setting the target. I'm interested in how the CO2 emission targets be set, like in 2050. So is there any focusing methods, or this is by quantitative methods, or this is some by experience set by the government, or any other approaches?
Do you mean our political targets to reduce carbon dioxide, right?
Yeah.
It's interesting. If I will come back to, if I can just start another place. Also now, when we discuss all this with natural gas and the Ukraine situation and so on. When I started entering this, when I was a young boy, when the first oil crisis was in 72 and 73, I was like 12 or 13 years. And later on, I entered this whole debate here. But in those days, it was all about oil dependency, supply, security of supply. we could not get the oil, and in Denmark we was extremely dependent on the oil. Everything was oil, cars, power stations, oil boilers, everything was oil. And then later on in the early 80s, we could get the oil. The problem was we could not afford to pay for it. It became an economic problem. And also we had unemployment, deficit on the balance of payment. We have all kinds of problems in the 80s in Denmark. So this became a matter of economy, where we also discussed maybe it is better to buy a wind turbine that is produced in Denmark rather than buy some oil that is produced somewhere else that we have to import. Maybe we can better generate our own economy by doing this. Became an economic issue. Then in the late 80s, in the early 90s, starting in 89 with the Brundtland report, the UN report on environment and development, then it became an issue of climate change and environment. And then later on, when the prices on oil raised again, they decreased in the mid 80s. Then it became a matter of prices again. And now in this week, or maybe this year, it becomes a matter of energy security and getting rid of being dependent on the imports. So all this reason here, I have for many years said that each of the three reasons, not being dependent on imports of oil and gas if you cannot get it, and the other reason, the climate change, and the third reason, the economy, how we can develop our economy in Denmark and develop an industry that we can, and so on and so forth. All of those reasons, each of them are so important that that we could do it alone for that one reason. But as we have three so major reasons, and the solution is exactly the same to all the three challenges, then there's no doubt in my head that it is good to do it, and we should have done it even more in the past. But but it's good that we at least did what we did so far. So and then coming back to your question here, the government in Denmark used to concentrate on oil dependency in the 70s, then on economy in the 80s, then on environment and international markets and so on in the 90s, and then back on the economy again, and then in recent years on the climate change. And now they sort of have a sole focus on the climate change, and they have defined these goals. The Danish Parliament stand united and have confirmed the same goals for 2 decades, shifting 3 or 4 shifting governments between the left and the right part of the Danish Parliament and so on. So they stand united in this goal of decreasing carbon dioxide, or it's all climate gases, but measured in carbon dioxide equivalent, decreasing it by 70% in 2030 compared to 1990, the UN numbers, and also becoming climate neutral in 2050. That's how it's been. And they stand united in this, and they have even set up a council that have to evaluate the government every year if they're doing it or not. and the politician is debating it, and everybody's debating in Denmark how to do it, and we're doing. The last election we had in Denmark was called a climate election because it changed a number of seats in the parliament, because the voters claimed that the climate was much more to the top of what they were concerned about when they had to vote compared to how it was earlier. So this is a major issue. And also recently we have a Prime Minister, Mette Frederiksen, who's a social democrat. And she used to say, I am red as a socialist before I am green. I'm more red than I'm green. But just, I mean, this month or last month, she has said openly in the television, we have changed our mind. We are as green as we are red now. It's not second to being socialist. It's on the same equal level. We are doing both, and there's no contradiction or something like that. So this is really important for the government and the people of Denmark and the government stand united, and there's also an attitude that we are willing to do this even though it will cost us something.
Thank you very much for your explanation. And yeah, we have another questions also from Zhongshu Ya. So Prof. Lund, would you
Excellent.
mind talking a little about the energy journals taste of publishable papers in these 3 years, or any new trends? Thanks. I think this is questions we all very interested in.
Yeah, of course. First of all, when I took over as editor-in-chief in, I think it was in 2009, if I remember correctly, I asked how many papers, how many submissions are we talking about? And I was told 600 a year. The first year it was 900. Last year it was more than 11,000. So it's been really increasing. So that's at least one trend in energy. There's a lot of the increasing number of papers. And originally, when this was started by Professor Penner and later on normally when it was started by Penner, energy, it was meant thermal energy, with thermodynamics. And was not meant electrical energy or chemical energy or something. It was meant that, but it has been rated in the very top of scientific journals within thermodynamics and XED analysis and stuff like that for many decades. The journal and still is. But Norm also opened it up. He broadened it up. So. And I did too, and we sort of redefined the scope a little bit. We say that we are still a journal with a thermal engineering history. That's who we are, but we are very, very open to all kinds of cross-disciplinary scientific topics, such as combining energy with economy, or combining thermal energy with electrical energy, or whatever, biomass, energy efficiency, energy conversion, or all related things. Only we say, as long as you're not going so far that there's no thermal engineering left in what you are combining, then we say it's out of our scope. And then there's a lot of very good journal, applied energy conversion management, energy policy. There's a lot of other good journals where you can publish that. So that's what we sort of say for the scope. But as you know, personally, I'm very much an energy system analysis type of person and energy planning. So this type of papers, holistic papers, are very welcome. And what we then do in the journal is we do our best to have to handle the paper as fast as we can do, which is a little bit difficult because there are so many papers. And then, of course, we look for having those within the scope and reject them out of scope as soon as we can if they are not really in our scope. If I should say a little bit about what I feel important to communicate to potential authors, that is not always easy to to communicate is that sometimes I said that basically all publishing is only about one thing. And if you stand that one thing, then the rest is just a consequence. And that one thing is that publishing, scientific publishing, is all about publishing some novelty scientific something, results, theories, whatever, some novelty scientific something that is not already published and is relevant for an international audience because it's an international journal. If you sort of reckon that, then you can understand why we, the editors, behave as we do. The first thing we look for is this already published? And then there's no need to publish it again and again and again. And we get papers sometimes that is, there isn't even an expression that is called salami papers, if you know what I mean. You cut one slide, you cut another, and there's really nothing new. It's the same salami. You just publish it with small changes all over again. And this is something we try to avoid, of course. So we reject those papers. We look for something that is qualitatively new. So, and one of the important things for us is that a paper already in the abstract, but at least in the introduction, is having a clear explanation of what is the novelty scientific contribution of this paper. And you cannot really do that without making a little bit of an introduction and survey what have already been published and why what you are publishing in your paper is not the same. What is the difference? What is the contribution? So that's why it's very important for us in the introduction and also already in the abstract that the authors say they published this and then they said that and then this and then that, and now nobody said or surveyed this or investigated this. This paper is investigating this and thereby adding to what all the rest of the scientific people said before. And then it's essential when you come to the conclusion that you actually conclude on what you have investigated and again repeat why this is new and what's the new. There's always some new stuff, but you also have to tell what the new stuff is. That's very important. So that's one piece of advice. Another piece of advice from my point will be always have a small, sorry, not a small, a short and easy understandable title. That's how it's easy for the editors to see what it's about, but that's not so important. The important thing is that's how it's easier for your readers to find your paper and read it and make use of it afterwards. So have a short and precise title and don't use all kind of abbreviations that nobody have heard about in the title already. If you have abbreviation, explain them and so on. And if you then, after the title, can have a short abstract where you actually synthesize what is the new knowledge contribution and also indicate why it's new and also end the abstract with exactly what the contribution is, of course, in very short terms. That's my feedback on that question.
Yes, thanks a lot for your advice and important message to us. So thanks again for Professor Lund's response and for the questions of our audience. So now next we invited our seminar coordinator, also our colleague Dr. Ray Zhong, to introduce more about our seminar series and upcoming seminar series, and also give us the ending message of this seminar. So welcome, Dr. Zhong.
Okay, thank you so much, actually, Professor Lund, for the very interesting and insightful talk. This talk actually is very comprehensive with the data support. Thank you again. And ladies and gentlemen, I would like to also promote the Leaders Series seminar. So I would like to acknowledge the previous speakers. So until now, we have about 20 world-leading scholars, and most of them are the editor-in-chief from reputable journals. And thank you so much for the great support. So in the coming speaker, we invited Professor Francisco Sandoval de Gama, is the editor-in-chief of Computers and Operations Research. So his talk will be on the 23rd March, also Wednesday, the same time, 8 p.m. Hong Kong time zone. So please keep your eyes and welcome to join us for Professor Francisco and de Gama's talk. And finally, I would like to thank you, Professor Lund, again for the great support. And we hope to invite you actually, pay a physical visit to our department and to Hong Kong U.
Thank you very much. It's been my pleasure. And thank you very much for the kind invitation. I hope really I can join you in physically.
Yeah,
the
sure.
sooner
It's
the
a
better.
great pleasure as well.
Thanks.
Yeah, I wish everybody, stay safe and look after yourself and each other well. Take care. And thank you, Dr. Huang.
Thank you, Rai, and thank you, Yong Hong, and thanks for our all organizing committee, and also thanks again for Professor Lund's seminar, and thanks all for the audience. So I think that's the end of our seminar today.